Piecewise functions. Don't let them scare you. Take them, literally, no pun intended, in pieces. Don't let them scare you. Okay, so we're going to evaluate these things. We want to find f of negative 3. When we're finding f of negative 3, we have to find the piece of the graph that contains negative 3. Just for the sake of going through it, let's start at the bottom. Negative 3 is not between those. Negative 3 is not between those, but it is between those. So we're going to use this piece, which corresponds to that. We are going to plug a negative 3 right there. Negative 3 squared plus 6 times negative 3 plus 9. I want to warn you about something, and I wrote it this way intentionally. First of all, I don't want you to rely on your calculator so much. However, when you type this in the calculator, it's going to lie to you unless you are aware of this. Negative 3 squared is positive 9. The calculator doesn't realize that because the calculator needs parentheses. Okay? So, when we plug this in, I'm not going to use a calculator. 9 minus 18 plus 9. Oh, neat. That gives me 0. So the first one is 0. Okay, we're going to find f of 1. We need to find the one that contains, well, 1. So 1 is not in between those. 1 is, oh, there it is. It's this one. So we're going to plug it in there. So please don't use a calculator on this one. Negative 2 times 1 plus 3. Negative 2 plus 3. The answer to that one is 1. Okay, it's not in there, but just for the sake of argument, just for the sake of explanation, let's suppose I gave you f of 2. Let's pretend. I'm going to squeeze one in there just for fun. If I gave you f of 2, we would need to know which one to pick. Obviously not here, but now we're torn between one of these two. Well, in this case, x is between negative 1 and 2, but it would include this one, but it would not include that one. Notice there's no equal mark. So if I had to use the number 2, I would use this one here. So the number 2, if we evaluated it, we'll do it. It won't take but just a second. 2 minus 2, square root of 0 is just 0. Okay. All right, f of 4 does contain 4. We're going to plug it in right there. Square root of 4 minus 2. That's the square root of 2. Square root of 2 is 1.414. Round as many decimal places as you want. We're not going to get too picky with that. Now we need to graph it. Okay, don't panic. We are going to do this in pieces. I'm going to start with this one. It is a parabola. I only need to worry about the numbers between negative 4 and negative 1. So over here on the side, I'm going to make a chart dealing with just this function in that interval. Okay? So our x values and our y values. Negative 4, negative 3, negative 2, negative 1. Now, some of you are about to argue with me on your computer because I put a negative 1 in there, and I know what you're thinking. You're thinking, but it doesn't include negative 1. I completely agree. It does not include negative 1. When we graph this function, we will put a point at negative 1, but this point is going to be an open circle because it does not include negative 1 when dealing with this function. Just for the sake of explanation, let's write that function. X squared, 6x plus 9. If we, if we plug a negative 4 into this function, we're going to get, let's see, 16 minus 24. 16 minus 24 plus 9. That's going to give us positive 1. Yeah, it is. Okay, we've already figured out this next one. We cheat and do that one. Okay, plug in a negative 2. Negative 2 squared, that's 4. 4 minus 12. Negative 8 plus 9, that's also 1. And then we're going to plug in a negative 1, that's 1 minus 6. That's negative 5. Negative 5 plus 4, that is 4. Okay, let's graph. Let's start graphing. -4, 1 is on my graph. -3, 0 is on my graph. -2, 1 is on my graph. And -1, 4 is not, but I'm going to pretend like it is, open circle. This portion of my piecewise function is a piece of a parabola like that. You might be tempted to continue your parabola up here. There, do not do it. It's not correct. And the reason it's not correct is because this piece of the piecewise function only exists between -4 and -1, but not including -1. Okay? We will now graph the second piece. I'm also going to graph it in red, and I'm not going to make a table for this one, and I'll tell you why I'm not. This is a linear equation, and we've been graphing those for forever. We will use slope and intercept. The y-intercept is 3. Up to 3. Put a point. I know it contains this point right here. The slope is -2. Let's be technical. That's -2 over 1. So we will go down 2 and over 1, down 2 and over 1 more. And while we're at it, let's go up 2 and back 1. And we're going to connect these points. Before I get carried away connecting these points though, I want you to realize that this function only exists between -1 and 2. Only here. From -1 to 2. But not including 2. Going to make this an open circle. And again, it goes back to what I said. When I plugged in a 2, I didn't plug it into this one. So that point better not be on my graph. It better be an open circle. So we're going to connect those hopefully with a straight line. I'm doing this freehanded. We'll see how that turns out. Not too bad. Okay. Let's keep going. We're going to graph this one. This function only exists here. Let's make another one. Y equals square root of x minus 2. This one's going to have a couple decimals in it, but we'll get over it. It starts at 2. It ends at 4. Of course, there's a 3 in there. Okay. We already know a couple of these points. We know them from over here. So we plug in a 2, we get 0. We plug in 4, we get the square root of 2. We'll kind of get all decimally with that one. And then when we plug in a 3, 3 minus 2, it's 1. Square root of 1 is 1. We're going to plot these points as well. We'll plot them in red. All of these points, these endpoints, and of course everything in the middle is closed. So this is closed. Oops, wrong color. This is closed. And this is closed. All right. So, 2, 0, closed. 3, 1, closed. 4, and then 1.414 like that. It's closed, and it goes like this, and that's it. Don't continue it. A square root function would continue, and it would go like that, but we're not going to continue it. Okay, there are a couple other questions on this page, though, that deal with domain and range, and we've not dealt with that for a piecewise function, but that's okay. It's not going to be that bad. So, what's the range for step 1? Well, I don't know. Well, first of all, let's state the obvious. This is step 1. This is going to be step 2. And this is step 3. Sometimes they're referred to as steps. You can call them intervals, you can call them steps. I call them pieces of a piecewise function. It's logical. But with step 1, we're dealing with that. So what is the range? Range, of course, is the y values. And so we want to know what y values are covered in that piece right there. Let's go ahead and look at our graph. We know what the graph looks like. The y values that are covered in our graph with this piece right here, well, we know the maximum is at 4. It is not 4, but it is almost at 4. It's an open circle. The minimum y value represented with this piece of the graph, looks like a fish hook. The minimum y value is 0. The maximum y value is almost 4. We're going to write it like this. The range for step 1 is going to be all of the y values in between 0 and 4. Not quite finished yet though. It does include 0. It does not include 4. Do not put an equal sign right there. The range for step 1 has a minimum at 0 and a maximum at 4. Okay, the next question says, what's the domain for the entire function? So the domain for f of x, and of course the domain is going to be the x values. So we need to see what x values are represented on this function. And there's a couple ways of doing it. We're going to look at the graph. The graph, in terms of the x-axis, it begins at -4 and it ends at +4. And nowhere in between does it cease to exist. It is broken. We have graph pieces flying all over the place, but the graph exists with every x value between -4 and +4. And that's clear from up here as well. It starts at -4, it ends at +4, and every number in between is accounted for. Where it's not equal on one number, it is equal on the next step. Where it's not equal on this step, it is equal on this step. Every number between -4 and +4 is represented in this domain.